Hi, I realized that I have to get to know you better, and I hope you can understand my style. But first of all, I forgot to tell you that I'm Mrs. Kumar. You can call me Mrs. Kumar, Mrs. K. Alright, so we have Max with Kumar. Now we are just going into curve sketching. We did in the last lesson, and I brought you through from linear to quadratic, and then I even went to a little bit more advanced, 1 over x squared. And I believe, and I'm very convinced, my dear, that you are picking up really well. But before we go a little further, all right, can you tell me, how will these shapes of these various graphs look alike? Do you notice my trend? I give you numbers that look alike. I write they look alike, and they may have the last exercise. I give you y equals to 3x, y equals to 3x squared, y equals to 1 over 3x, and all kinds. We played around with it, and I'm sure you have a picture now of curve sketching. Look at this, x squared minus 1, x squared plus 1, 1 over x squared minus 1, 1 over x squared plus 1, and now this 1 over x minus 1 squared. Right, they look so much alike, but they are very different in many ways. A quick revision in curve sketch. When we draw a sketch, we've got to look at few pointers. What are they? Yes, we look at turning point. That's one thing. But what else do we look at? When I put CS, I meant curve sketching. You look at a turning point. But before that, what must you be concerned about? Yes, when x is 0, what is happening to y? Second point, when y is 0, what is happening to x? That's great. And we also want to see the behavior of x when it approaches infinity. Alright, when x is approaching infinity, what becomes of y? Is it approaching 0, or what does it approach? Is it an ever-increasing function? When x approaches infinity, y approaches infinity. Like y equals to x cubed. Remember we did it? Y equals to x cubed. We learned here that when x is approaching infinity, y is also moving upward. And when x is approaching minus infinity, y is approaching minus infinity. Alright, that's what we're talking about. Now, we are also concerned about plus and minus infinity. Similarly, we also want to find out if there is any term, any line they can't cross. And what do you call that? Yes, asymptote. You love that word, don't you? asymptote, an asymptote. Are there any? And the next important point that we taught about is turning point. All right, in Singapore, we have a polytechnic that's called Temasek Poly, TP. All right, so that's not TP. We are talking about turning point. And we talk about turning point. Is it a maximum or is it a minimum? All right, is it a maximum or a minimum? And we also learn that when the order is 3, the maximum number of turning points is 2. When the order is 5, the maximum is 4. Alright? And in the case of this, y equals to x cubed, the last lesson we learned, there's no turning point. In fact, there's this term called what? Point of inflection. So you want to find out about turning points. You want to find out if there's any point of inflection. Inflection. Want to turn, doesn't turn. Alright? And students at a more advanced level, you know what it is all about. A gentle reminder is about differentiation in calculus. We find that when you find turning point, you find dy dx. Don't worry those who don't understand. I'm just bringing a little shift to those who are into further maths. Alright, you find dy dx when dy dx is 0, at what point? And then you want to find turning point, you look at the second derivative after that. d2y dx squared. You look at these two. Alright? And if your second derivative is still a 0, then you get a point of inflection. But as for you, if you're not doing further maths, you can see very clearly, hey, my x is increasing as my y is increasing, or is dropping as it is. If you look at this, y equals to minus x cubed. Alright, we just did it. The last lesson, x is dropping. Y is dropping. As x goes this way, y is dropping. Alright, so you see that it's supposed to turn, but it did not. And this is called the point of inflection. Alright, so if you look at all these, and you have a good understanding of it, and oops, I forgot to add something important. What's that? When a graph cuts the x-axis, what do you call that? Roots. Yes, roots means solutions, and it's good if you can find the roots of the graph, right? The point. So you look at roots. That is when it cuts the x-axis. What are the points? With all these as pointers, you can do very easily a curve sketch. Alright, a very quick one. X is 0, what is y? Y is 0, what is x? When x approaches infinity, what happens to y? Either positive or negative infinity. And are there any asymptotes? And also, if there is a turning point, how can we determine the turning point? Now this is where later I'm going to give you a value add information on turning points, how we can use completing the square in finding out the turning points for quadratic equation. We'll learn more about that. Alright? And then we also know about point of inflection. I think you're familiar with the word. Want to turn, do want to turn. So it's just a move. And we learned about roots. Alright? Let's get back now to the sums. Y equal to x squared minus 1. What is the shape of the graph? Well, we all know that y, when it's equal to x squared, when y is equal to x squared, is a parabola, right? And there's one root. When x is 0, y is 0. So curve goes this way. Got it? And when y is equal to x squared plus 1. Now, we're going to move it one step up or one step down. Okay, let's look at this then. X squared minus 1. What happens to a graph? And it is x squared plus 1. Let me bring you to a more detailed, a bigger sketch on it. Let's see what happens. You see, this is too close to my margin, and I need to give a space to it. So be very careful when you draw your lines and your graphs. Y is equal to x squared. And when I want x squared minus 1, you just move the graph one step down. This point, when x is 0, y is minus 1. And the graph goes this way, y is x squared minus 1. And when the graph cuts the axis, we can find out the points. We can actually factorize it, and we did it in the last lesson. X plus 1, x minus 1. So this point, when y is 0, you get your x to be minus 1 and 0. Here, your x is 1 and y is a 0. Now what about y equals to x squared plus 1? Well, we move the graph of x squared one step up. So we say, hey you, when x is 0, y is 1. So look at this graph. This graph here, the name of this graph is y equals to x squared plus 1. What does this graph tell you? Are there any roots? No. Why no roots? Because it's not cutting the axis, the x-axis. So there's no roots. And anyway, I like to let you know y. Look at this, x squared plus 1. When I make y equals to 0, let's put it as 0. Your x squared is going to be a minus 1. And can we find the square root of a minus 1? Your calculator will say, oops, error 2. Right? You can't find the square root of a minus 1 right yet. It actually falls under the complex number series. So please take note of this. So there's no roots. This tells you that there's no roots for this sum. And I'll tell you more about roots in my value add, which shall be doing shortly. Now, let's move on. So we've covered here 3, x squared plus 1, x squared minus 1. How about y equals to 1 over x squared? I'm going to group them here. And I have y equals to 1 over x squared minus 1. How does that behave? Alright, I'm sure you want to know. And y equals to 1 over x squared plus 1. Let's put on. Is that going to be a hassle? I'm sure not. Now let's look at this graph. Y equals to 1 over x squared. We learned it that this is going to be positive. Whatever values of x, even if it's negative. Y? Minus and minus, x is negative. Repeated twice, it becomes positive. So this is the shape of this graph. Y equals to 1 over x squared. But now, when we look at this graph, y equals to 1 over x squared minus 1. This whole graph is shifted one step down. Move it one step down. It's made of this graph and moving this graph one step down. So when you move it one step down, this is called the asymptote. Alright, when you move it down, and this line, y is equal to minus 1. Alright, y equals to minus 1. Your graph is going to go downward and it's going to be this way. We're going to draw it. So let's find out. It will be cutting the x-axis. And you want to know what happens when it cuts. This is the x-axis, this is the y-axis. So let's find out more. There's no need to guess. We can just work that out. No need to guess. How do we work it out? Look at that. This line, x-axis, is none other than another name, y equal to 0. Yeah. So let's look at that. 1 over x squared minus 1 is your y. At the x-axis, when it crosses, y is 0. Right? So you can see that 1 over x squared is equal, bring the minus 1 over, you get a 1. Bring your x squared over, alright, divide, you get your x squared to be equal to 1. Find the square root of it. So you can see that your x is equal to plus or minus 1. So this beautiful information is very crucial. It helps you in drawing your graph. How do you do it? Now, right? When y is 0, x is minus 1. And y is 0, x is plus 1. 1, 0. And now, this is the line of asymptote. It can never go below that because We have pushed this graph down, so the graph goes like that. The graph goes like that. Alright? So the name of this graph in red, I hope you can see it beautifully. Alright, this graph, I'm emphasizing on it, but please, when you do it, make sure the points are clearly seen. The name of this graph will be y equals to 1 over x squared minus 1. That's the name of this graph. Have you got it? Is it possible? Do you understand what is it all about? Because you know the graph, how to draw 1 over x squared, that makes it a lot more easier, isn't it? Great. Now how about this graph? What happens if we say plus? What's the shape of the graph? Can you be able to guess it now? A quick sketch of it. Well, the 1 over x squared, alright, I'm looking at it here, 1 over x squared plus 1. How do you draw it? Well, it is again this graph moving one step up. So when the graph moves one step up, when you look at here, alright, there is no roots. And the graph, the line here is y is equal to 1 will be the asymptote. Move it up and move it up here. So the name of this graph is y equals to 1 over x squared plus 1. Is this shifting the asymptote from here, y equals to 0, to y equals to 1? Alright, now so much about curve sketching, this part of it. Now I'd like to bring you back to another little component, right? We just learnt about y equals to 1 over x squared. What happens if I change this? Look at this movement, remember. We did all this, right? How about this? Are you going to have a struggle? Can we give it a big name? Change the name. X minus 1. Let it be a big X. Will it be the same as say, I'm looking at part 5. I say, hey, you y, you're 1 over big X and squared. Why not? Right? But what does big X equal to? Your big X is none other than x minus 1. We know very clearly that this bottom, the big X, can never be 0 because 1 over 0 is infinity. Yeah. So x minus 1, alright, this can never be 0. So we can form a little line and we said, hey, x minus 1, that's your big X, right? Okay, can never be 0. So your small x can never be equal to 1. That's your line of asymptote. I hope you got that. Alright, asymptote's a line you can't cross. So with that understanding, what will be the shift? How will the graph look like? Can you do a sketch on that? Alright, so let's match what you've done and what I've done and see if you got it right. Let me play with a little bit of colors. I love green. Let's look at that. So x can never be 1. We draw this line of asymptote and we call this line x equal to 1. That's called an asymptote. And so the shape of the graph, because it's squared, x squared, look at this, x minus 1 squared. Whatever negative number it is, it becomes positive, right? And as long as it crosses the y-axis, another name for this is x is 0. So if you put an x as 0, minus 1, when you square it, becomes a 1. So 1 over 1 is 1. So this point here, when x is 0, y is 1, the shape of the graph is like this. Hey, x is 0, y is 1. And here, the shape of this graph goes like this. Got it? So it's just a shift, alright, with the asymptote shifting. Will that make it a lot more easier for you? Similarly, if I were to ask you, my dear, this is 2x minus 2 squared, the asymptote will be a 2, and the graph goes this way. Are you all clear? I put x plus 1, the shift will be this way, alright? X plus 1 can never be 0. So x equals to minus 1 will be the asymptote. So graph goes this way, this way. I hope you've got a better understanding. Right, we will move on more with curve sketching. Right, next with Kumar.